Alright, here are some review test problems for the quadratic function. So we need to be able to take an equation, identify the vertex, focus, directrix, axis of symmetry, and sketch a graph. So one option, you may want to just throw this in your graphing calculator and find the minimum or maximum. This one would actually have a minimum because the a value there is positive, and kind of go from there, because the vertex is kind of the driving force where all this other stuff is going to be located. But the other option is to actually just convert to vertex form. It's a little messy with the fraction in there, but we can do it. Remember, vertex form is going to be y equals a times x minus h squared plus k. Okay, and then the a value is same as the a value in standard form. So we have that value given to us. And to get into vertex form, if we want to just take what they gave us, we can see the a is factored out front. So I'm just going to bring the 1/4 out front. Now the trick is you want to actually just factor it out of these first two terms. Okay, so if I factor the 1/4 out, I would be left with x squared. Now factoring the 1/4 out of the -2, when you divide by 1/4, it's like multiplying by the reciprocal, which is multiplying by 4. So the minus 2x would really become now a minus 8x. And then we're going to complete the square. And the plus 5 that was still sitting here is still going to be in the problem. I'm just going to leave it out there. And what I like to do is leave a little space to remind myself to balance out. Whatever we put in that first blank space, we need to balance that out. Okay, and what's ended up happening here is this x minus h squared is going to come from factoring this quadratic here, and that's why we're completing the square. And just to finish it up, I guess the k term is going to come from whatever those combine to equal. Okay, so let's go ahead and do the completing the square. That process again, we look at the minus 8 we have here. We take half of that to become -4, and then squaring the -4 does become a positive 16. Okay, so we kind of threw a plus 16 in there. We need to balance that out, but remember the plus 16 is actually getting multiplied by that 1/4 there, because the 16 is in parentheses, right? And the 1/4 would get distributed to it. So 1/4 of 16 is really like we just added 4. So to balance out adding 4, I'm going to go ahead and subtract 4. And now we can get our final completing the square. Our final vertex form, I should say. The yellow highlighted term is a perfect square trinomial, x minus 4 squared. And combining the positive 5 with the minus 4 out there will leave us with a plus 1. Okay, so we know the vertex is going to be, remember, it's always the opposite of any inside term. So that minus 4 is really like a positive 4 in the x direction, and then up 1 unit in the y direction. So that's where our vertex is going to end up. And the graph will do something like this. Okay, we don't need to be perfectly accurate or anything here, but the vertex is at 4, 1. Okay, that's the good thing about vertex form, right? It shows us where that is. And now the focus, directrix, all that stuff is going to be determined by the focal length. And we have that one little formula to remember, P equals 1 over 4A. Okay, so for this specific problem, the a value, we knew the a value right at the very beginning was 1/4. Okay, so we're going to find the focal length by simplifying this expression here. And just remember, it's 4 times 1/4 in the denominator. That equals 1. So the focal length is really just 1. Okay, so what we know is that the distance from the vertex to the focus is 1 unit. So since the parabola opened up, the vertex, the focus, will be 1 unit above. So the focus is going to be sitting up there at 4 and 2. Okay, the y value, right? The y value is 1 higher than where the vertex was. And the directrix, the line will be that same distance, but it will be below the vertex. So it'll be 1 unit below. And it's just going to, in this case, be the x-axis. So the directrix, the equation of it is actually y equals 0. Okay? Each of those are 1 unit away from the vertex. Okay, and then finally the last piece that we need here is the axis of symmetry. That's always just going to go right through the vertex. Okay, and in this case it'll be a vertical line like that. So the axis of symmetry will be the line x equals 4.
Hey, Wyden.
Hey, good morning. How are you? Good, good. All right, and moving along here then we have, hang on. Okay, moving along then to number 2, they give us some of the properties. They're giving us, it looks like, a focus and a directrix. Okay, we want to find the vertex, find the value of P, and write the equation in vertex form. So if we think about, let's label what we have here. Here's the focal point, and then the line, of course, is the directrix. Okay, so we know the vertex is going to be right in the center. Okay, it needs to be the same distance from each. So it looks like right about there would be the vertex. So coordinates of the vertex are going to be +1 for x and -1 for y. Okay, I also know the parabola always opens towards the focus, so it's going to do something like this. Okay, we don't need to be like perfectly accurate. Again, it's just a sketch just to help us. But what that allows me to see and find is the value of P. Okay, P measures, remember, the distance from the vertex to the focus. So that distance is clearly 2 units. Okay, and we had the coordinates for part A already again at 1 and -1. Okay, now to help us find the equation, this one does open sideways, so it's going to be an x equals equation. Still find an a value. When it's an x equals equation, it'll be y minus k squared plus h, okay? Because the h always goes with x for like horizontal, and then k is used for the y coordinate of the vertex. Okay, so if we think about, we need to find that a value. Okay, it is related to the focal length p, right? A is always 1 over 4 times p, and p in this example was 2. Okay, so we have 1 over 4 times 2, we have 1 over 8 for our value of a. So that means the equation of this parabola, it does open to the right, so the a is positive, so +1/8. Okay, and now as far as the y minus k, remember the inside part is always the opposite. So the y coordinate of the vertex is technically -1, but we're going to do the opposite and make it a +1 in there. And then the horizontal, the x coordinate, is actually not the opposite. It actually is +1, so we're going to use a +1 there. So that's going to be the equation of our parabola. All right, then moving on to number 3 here, we want to write the equation of a parabola that goes through 3 given points here. So there's a couple options to do this. One option is to use the standard form, y equals ax squared plus bx plus c. Use that standard format, and then just write an equation for each of the ordered pairs. So like, for example, for the point -2, -6, that equation would be setting the y value -6 equals a, which we don't know. The x here with that ordered pair is -2, plus b, which we don't know, times the x, which is -2, plus c. Okay, so I literally just plugged in the y and then the x in each spot, and just kind of simplifying those, the right side of the equation. The -2 squared is +4, -2 times b would be -2b, and then it would be +1c. And then doing a similar process, writing a second and third equation for the other ordered pairs, and then using the matrix method to actually solve for a, b, and c. Okay, so we have some examples of those. Feel free to check those out. What might be quicker though, and in this case, it did say use any method. So on your calculators, you can use the quadratic regression feature. Okay, and that one just involves that stat button on your calculator. You enter the 3 ordered pairs into L1 and L2, and then you can just go back to stat and do the quad regression like we did in class. And just to verify that, your answer for that one should be a final equation of y equals, it looks like the a value was 2, so 2x squared, the b value was 4, and then the c value was -6. So 2x squared plus 4x minus 6. Same answer you should have got using the matrix method to solve the 3 variable system. Okay, so that's how we can get an equation to fit the points, and you can always verify that if you graph that, make sure it does go through the 3 points. Now part B wants us to rewrite that in vertex form. Okay, so with vertex form, we know it's going to look like y equals, the a value will be factored out, and then there'll be the x minus h squared plus k. And the h and k, again, are going to be the coordinates of the vertex. So it's going to let us see the coordinates of the vertex really quick. So based on what we have so far, we have the a value is 2. Okay, so if I factor out that 2, and the trick is only factor it out of the first two terms. It just makes the process a little easier. So when you factor out or divide a 2 out, we'd be left with x squared and then just plus 2x. And then we're going to complete the square there. The minus 6 is still sitting outside there. And then I like to put a little space there just to remind myself to balance out. Whatever we're about to add in the parentheses there, we need to balance out. So the completing the square process again is we're looking at the middle term of 2 and we take half of it and then square that. So the 1 squared is still just 1. So we're going to throw a plus 1 there. And what that is going to do is it's going to make this become this, because the highlighted expression there, x squared plus 2x plus 1, is really just x plus 1 times x plus 1. Okay, so it's going to be x plus 1 all squared. But before that, we do need to balance out. We can't just throw a plus 1 in there. Do keep in mind, though, that plus 1 is really getting multiplied by the 2 there. So we really did a plus 2 in a way. So I'm going to balance the plus 2 out by subtracting 2. And now we can write our final vertex form by just simplifying. So the 2's out there. The yellow highlighted, like we said, becomes x plus 1 all squared. And then on the outside, the minus 6 minus 2 more does become a minus 8. Okay, so that lets us know that our vertex would be at the coordinates. Remember, it's always the opposite for the inside, the parenthesis term. So it's -1 for the x and then -8 for the y. Okay, and that's going to help me identify the axis of symmetry in part C, because it always goes right through the vertex. Okay, so if this graph, just a real rough sketch, so -1, -8 might be down here somewhere. I know the graph opens upward because the A was positive. That just lets me know that the axis of symmetry, okay, right through the middle there, is going to be at through the line x equals -1, okay, because that was the x coordinate of the vertex. Okay, and then finally, part D, use factoring or the quadratic formula to find zeros. So zeros, again, are going to be where the graph hits the x-axis. So we want to go ahead and use, I'm going to use the standard form up here that we found in part A. I'm going to use this and try to find out what would make it equal to 0. Okay, and there's options, there's different methods on this. We could even use the vertex form and do some different steps. We did some of that, but I'm just going to solve it in standard form here. I'm going to use the quadratic formula, even though this one is factorable, because just remember, not everything is factorable, so I just want to review that quadratic formula process. Okay, and one thing I notice here, and you don't have to do this, but if you do happen to notice that there's a common factor, in this case 2 can be factored out of all of the terms, it'll just make your numbers a little bit smaller when you do go to plug into the quadratic formula. But if you didn't do it, you may just have to reduce the problem later on. Okay, so anyways, I divided a 2 out, factored the 2 out, and then now if I were to divide both sides by 2, we would cancel out that 2 that we just factored out, and the left side of the equation is still going to be 0, right? If it's 0 and you divide by 2, it's still 0. So it just gives us this little bit of a simpler terms to use, smaller, reduced numbers, right? And now we're ready to plug right into our quadratic formula that tells us x must be the opposite of b plus and minus square root of the b value squared minus 4 times a times c. C is -3 here. And that whole thing divided by 2 times a. Okay, and then we just want to go ahead and simplify and reduce everything down. So the -2 plus or minus. So under the square root here, this discriminant, it's called, right? We have 2 squared, so we have 4. And then we're minusing 4 times 1 times -3. So we're actually subtracting -12, right? So 4 minus -12 is going to give me positive 16. So just be careful on that step. Okay, and then this one is, we're able to simplify a little bit more because we know what the square root of 16 is. It's just 4. Okay, so we have -2 plus and minus 4 all over 2. Okay, and just keep in mind those need to be added and subtracted before we divide. Okay, so we go ahead and split that up into the two cases. We have negative 2 plus 4 over 2, and we have negative 2 minus 4 over 2. Okay, and then simplifying those to get our final answers. Again, remember, evaluate the numerator first, right? Negative 2 plus 4 is 2. That divided by 2 is 1. Okay, and then finally, the negative 2 minus 4 is negative 6. Dividing that by 2 gets us negative 3. So that would, in fact, be the zeros of this function. And again, you have the equation. You can verify that graphically and just make sure it seems appropriate. Okay, and then lastly, being able to write the equation given a quadrant and a direction of opening. Answers are going to vary, but basically there's some major things we need. First off, just to know that the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So if we want to be over in quadrant 2, okay, the important thing is that over there the x's are negative, but the y's are positive. Okay. So for a parabola to open downward, we know it's going to be a y equals with some negative a value. It could be any number you want. Okay. I'll get specific numbers in a second, but just some negative number, and then it's going to be x. To get the x over here, it's going to need to be a plus some number squared. Okay, that's how it shifts left. And then to get the y-coordinate up in quadrant 2, it's going to need to be plus some number as well. So you could put in any numbers you want, as long as this is a negative, negative 2 times x plus 1 squared plus 1 or whatever. Okay, so what I'm looking for to make sure that it's correct is that that's negative, that's positive, and that's positive. That will get it in the correct quadrant and open in the correct direction. All right.